Hello, my name is Emery Hill, and I will be presenting my lab on parabolic motion and maximum height. So to start, the whole purpose of this experiment is to predict the max height of an object being thrown in a sort of parabolic motion. So in the lab, I had a friend throw a marker to me upwards. Behind this, we have a lot of physics at work. Newton's first and second law are very important. They are the basis for all of our formulas that we use. So we have kinematics here. Obviously, when we're throwing an object, there has to be kinematics at work. Position update and the first kinematic equation are very important for this. And then average velocity formula allows us to estimate initial velocity in our coded model. And then drag force, we're just throwing drag force in here as well because that was used to make it more accurate. Now, Tracker was used to extract data from the video, and then GlowScript was used to code the second model. So each of these made one of our models. For a quick preview of the main results, you can see both models overlaid onto one here, and the maximum heights there at the top of the curve are almost exactly the same, which is what we are kind of looking for. And then the differences in the curves anywhere else can be explained through some physics, which we'll get into. First, I want to recognize the system surrounding and initial conditions. The system is the marker, nothing else. The surroundings is everything else, the air, the ground, anything that affected the marker's motion. So drag force, gravitational force, all of that. It started with an initial velocity of 4.2 meters per second at time equals 0 and position is 0. And it's important to also recognize anything in the x direction here we can kind of ignore because we're looking at the y direction motion for that max height. For the procedure, a video was recorded of the motion of the marker, and then it was put into Tracker, which gave us the data. And then that was our first graph. And then initial velocity was calculated with average velocity formula. And then along with that, an initial position, drag force, gravitational force. The second model was made, which is this graph here. And then both graphs were put into one on Google Sheets. For the coding in GlowScript, it was actually relatively similar to some of the past labs. I just had to input our total time, initial velocity and position, delta t. I had to calculate the drag force on the markers so that we're being accurate here, and then gravitational force and then net force, obviously, and our net force goes into the velocity and position updates as well. So we have both models, the Tracker model and GlowScript model. The Tracker model is the most accurate, obviously, because it is directly from the video. And so that's kind of the baseline for our GlowScript model, which is an estimation. The GlowScript model is a estimation of what we think the max height would be based on our initial values from the Tracker model. Now for the combined results, this is the graph here again. As we said, the max heights here are almost exactly the same. They're within like a couple centimeters of each other, so that's pretty good. And then anywhere else where they're not quite lining up, that's because of anything else, like the initial velocity may have not been perfect, as it was just taken from data points in a video. And then there's obviously other factors at play. There could have been some rotational energy. The marker was spinning a little bit, so anything else like that could have affected the motion of the marker. For our analysis and conclusion, I just want to recognize some similarities and differences. Both graphs had the same parabolic motion. As you can see, both had the same max height, give or take a centimeter. Both had the same starting conditions. So they're overall very similar. And then for our differences, they did separate at the end, resulting in final positions being slightly different. But overall, that's sort of unrelated to our purpose anyway. Now, the computational model was very accurate, so I think this lab was relatively successful. Just first to address some final questions, if the mass was greater, would the max height change? No, the mass does not affect any of the motion of the object as long as the initial velocity remains the same. So it really wouldn't change. The only difference it could have had was, air and drag wouldn't affect it so much, maybe. And is there a terminal velocity in the x direction? No. Because there's no acceleration in the x direction, there is also no terminal velocity in the x direction. Just to recognize some potential errors, a longer video could have made this whole thing more accurate. Air movement in the room can cause slight differences, and then human error with tracker is always possible while reduced. Thank you for watching.